This video provides a brief review of the substitution rule for indefinite integrals. Here we have the substitution rule, and the most important part there is that g of x is an inner function inside of f in that integral. And then we can use what's sometimes called a u-substitution. We let u equal g of x, the inner function. Its differential du is the derivative of g of x times dx. Now for some example. Here we want to find the integral of x squared of the square root of x cubed plus 12. So we can see x cubed plus 12 is an inner function inside the square root function. So letting u equal x cubed plus 12, its differential is du equals 3x squared dx. So the x squared dx is simply 1/3 du. Whenever the remaining part of the integral is just a constant multiple of the differential of u, then substitution will work fine. So we substitute into the integral there, and we get the right-hand side here, integral square root of u times 1/3 du. So we move the 1/3 to the other side of the integral sign and use the power rule here. Get 1/3 times 2/3 u to the 3/2 plus a constant c. Then substitute back in for u, and we get our final answer down here, 2/9 x cubed plus 12 raised to the 3/2 power plus c. Now, WolframAlpha is a very easily used and powerful program. It can do integrals like we just did. Here we have what I entered into WolframAlpha, integral of x raised to the 2 times square root is sqrt in WolframAlpha, parentheses around the x raised to the 3 plus 12. And then I hit enter, and the result is shown down here. Exactly what we found. Now, if you do subscribe to the pro version of WolframAlpha, then you can click on the step-by-step solution box here. I do have that subscription, and it gave. And you can see if you read through here that it's doing exactly what I did by hand in the previous calculation, and we get exactly the same answer that we found. WolframAlpha confirms our work. Now here's a second example, a little bit more complex. We see here the 5 tangent of x minus 1 is an inner function inside the square function down in the denominator. So if we rewrite the integral, it's a little more plain, again, that 5 tangent of x minus 1 is an inner function inside of the minus 2 power there. So we're going to use u equals 5 tangent of x minus 1 is our substitute. Du, the differential of u, is 5 secant squared of x dx. The derivative of minus 1 is 0. Derivative of tangent of x is secant squared of x. So we get du is 5 secant squared of x dx. So divide by 5 because there's no 5 in the integral that we're looking at. So 1/5 du equals secant of x dx. Substituting into here with the u and du, we get the integral here, which we can do by the power rule, and we get -1 u to the minus 1, so -1/5 u to the minus 1 plus c. Substitute back in for u, and we get the results shown down here. 1/5 minus 25 tangent of x plus an arbitrary constant c. Now it's quite interesting if we use Wolfram alpha here. Here I've entered in the integral of the function there using the syntax we need for Wolfram alpha, just like a graphing calculator. Although you don't have to write the times sign there, just 5 tan of x is, and Wolfram alpha will understand the multiplication. It does not give exactly the same looking result as we just found. We get sine of, Wolfram alpha says sine of x divided by cosine x minus 5 sine of x. But if we go through the step-by-step solution with the probe, here is what we get. Notice it's doing exactly the same steps as shown in previous work, and in fact, at a certain point, right, as indicated right here, it found exactly the same answer we found. What Wolfram alpha did apparently is do a conversion with some trig identities to the answer that it showed. I noticed that, as pointed out here, that it says that that's for restricted x values. So I don't really understand why it did that exactly, except perhaps to show off that it knows all kinds of trig identities. But using the step-by-step solution method, we did find exactly the same answer with Wolfram alpha as we did with our previous hand calculations. Again, the Pro version is not super expensive for a monthly subscription. You get a student discount. I would highly recommend that if you have something like $15 to $20 to spend, that you purchase the subscription and check your work with the step-by-step method. It's, I think, very helpful for learning calculus. Well, that concludes this video. Thank you for watching.